Hi everyone. This is lesson 1.3.2 of the Permutations and Combinations chapter, and in this lesson we're going to take a look at an application of combinations. We're going to look at pathways. So there are a few things that you need to take into consideration when you're approaching a pathway problem. And the first assumption that you need to make is that you're always moving towards your target. The next thing that you have to be really clear on is how to differentiate one pathway from another. And you do that by considering the blocks that the path travels around. This might not seem like that important of a point or that big of a deal, but it's often a point of confusion for people. When you start to prepare to do this question, you need to count the blocks implied by the problem, not the actual streets that you're traveling along. It really is the blocks that you're traveling around. If that doesn't make a lot of sense right now, believe me, it will after we've done a few questions here. And once you've counted up the blocks, if there are m blocks running north and south and n blocks running east and west, then there are a few methods we can use to calculate the number of pathways. One is to calculate m plus n, choose m, or as we've seen in previous lessons, we get the exact same value by calculating m plus n, choose n. Or you can simply think of this in terms of the factorial notation, or you might even think of it as a permutation with repetition. And you would write it as m plus n factorial over m factorial n factorial. Okay, let's take a look at our first example here. If a town has 3 streets running north and south and 5 streets running east and west, how many pathways are there that connect the one corner to the other diagonally opposite corner? And it really doesn't matter whether you start in the top left, top right, or whatever. This number of paths from one corner to another will be the same. So the very first thing you want to do, and I recommend this with all of these types of problems, is you want to sketch this out so you can see it. And with 3 streets running north and south and 5 streets running east and west, it's going to look like this grid right here. Now notice what we get from this when we have the streets running north and south create 2 blocks going east and west, and the 5 streets running east and west create 4 blocks going north and south. And since it is the number of blocks that are important in determining the number of pathways, we've now got all the information we need. If you think back to the little expressions that we used for calculating the number of pathways, in this case here we would say that m is equal to 2 and n is equal to 4. And so our calculation could be 6, the sum of the two, 6 choose 4, which would give us 15. Or we could use the other expression and write 6 choose 2, which would also give us 15. Or we could simply jump to the factorial notation and write it as 6 factorial, the sum of the two, divided by 2 factorial, 4 factorial, which again gives us 15. The way we might interpret this one is you might see any pathway going from one corner to the other as a series of motions being, like, let's say east, east, south, south, south. So there's 2 motions that would be east and 4 that would be south. That's like creating a word with 2 E's in it and 4 S's. And so what you're seeing here is the number of ways of permuting the letters in that word. But regardless of how you choose to approach this, there are clearly 15 pathways running from one corner to the opposite. Now let's consider a different question where the information is given to us in a slightly different way here. In this example, it says the school is 5 blocks south and 7 blocks west of a student's home. Assuming that the student always travels closer to his or her home, how many different routes are possible from school to home? Once again, I think the first thing we need to do here is sketch the scenario. And in this case, we are told the number of blocks going east and west and north and south. And notice that given those numbers, we need to adjust the number of streets that we're going to use appropriately. So 5 blocks running north and south mean that we're going to have 6 streets going east and west, and 7 blocks going east and west mean that we're going to have 8 streets going north and south. In this particular question, though, that bit of thinking is only important to get the sketch. We were told the number of blocks immediately, so we can really just jump into our calculations. And notice in this case that m would be equivalent to 5 and n would be equivalent to 7. And thus we can write that the number of pathways will be 12 choose 5, which is equal to 792. Or 12 choose 7, which is also 792. Or once again, we can think of it as a word that we're permuting that has 12 letters in it, because there are going to be 12 blocks really that we have to travel when we follow this path. But there will be 7 easts, let's say, and 5 souths. So we get 12 factorial over 5 factorial, 7 factorial, which again is 792. And now I really hope that I haven't confused a lot of people here. You don't need to do this question 3 times every time we do that. I'm just trying to give you guys some options here. There are 792 pathways from school to home. Now let's take a quick look at a different style of question. How many paths are there from A to B, assuming that you must always be approaching B and that you must pass through the point C? This is in the following diagram shown below. Now the first thing we might want to do in this question here is adjust the diagram and by removing the unnecessary parts of the grid. Okay, and that represents all parts of the grid that you would have to backtrack from to get to point C. And when we do that, you'll see that the result are 2 smaller grids that intersect at point C. So now any path that goes from A to B must pass through C. So to find the total number of pathways, we need to find the number of pathways from A to C and then multiply that by the number of pathways that take you from C to B. And the reason why we multiply is because the only way to go from A to B is to go from A to C and C to B. And that implies multiplication. So now we just consider the 2 smaller grids separately. The number of pathways from A to C can be calculated by letting little m be 4 and n be 6. And then the number of pathways from C to B can be calculated by, again, letting little m be 3 and little n be 3. And then as we stated before, the total number of pathways will then be the product of the number of pathways in both of those grids. Symbolically, we might write this as 10 choose 4 times 6 choose 3 to get a total of 4,200 pathways. Or, as I've suggested before, we might approach both of these as if they were permutations. And so the first grid would be 10 factorial over 4 factorial, 6 factorial. And the second grid would be 6 factorial over 3 factorial, 3 factorial. When we multiply those together, once again, we get 4,200. Now let's take a look at an example that's a little bit more complicated. This is a 3-dimensional problem. We've got to go from point A to point B, and we've got these 2 prisms that are intersecting at one point. Basically, we can crawl through these objects to find our pathways around these cubes now, as opposed to going around blocks. Now, it turns out combinations don't really work all that well for 3-dimensional problems. Now, what we have to do here to determine the number of pathways through a 3-dimensional object is to introduce another variable. So for the first prism, we're going to let m equal 3 and n equal 3, and you can see how those match up with that object. But now we're going to introduce a third variable, p, and we're going to let that be the number of blocks that we have to follow upward, and in that case, p would be 6. And then, in this case, the most appropriate way to think about how to answer this problem is to really think about it as how we would model it as a word. We're going to use E to represent motion to the east, maybe S to represent motion south, but then we're going to introduce a U to represent motion upward. And so this word that we're creating has 12 letters in it. There's 12 factorial ways to organize those letters, and those are all going to correspond to different pathways. But there's repetition here. There's 3 E's, there's 3 S's, and 6 U's. And so to account for the repetition in the word, we divide by the 3 factorial, 3 factorial, 6 factorial, which gives us a total of 18,480 pathways through that first prism. And now we do the exact same thing to determine the number of pathways through the second prism. We just have to identify the values of those variables again. In this case, m would be 6, n would be 2, and then p would be 2. And so again, we're treating this as if it's a word where each letter represents a motion. And so we've got 10 motions in this problem, so 10 letters. There would be 6 E's for east, 2 S's for south, and then 2 U's for upward. And again, to evaluate the number of permutations of a word with repetition, it's going to be 10 factorial over 6 factorial, 2 factorial, 2 factorial, for a total of 1,260 different pathways through the second prism. And then our final step is to simply find the product of those two. And so we take 18,480 and multiply that by 1,260 for a grand total of 23,284,800 different pathways from A to B.